What we're looking at is one of the defining paradoxes that has given us a little bit of insight into quantum mechanics, and it shows up typically in high school physics, but also in college as well. And that would be Schrödinger's cat paradox. And what this is going to do is give us a little bit of insight and appreciation of what really is a measurement when we take those in science courses, labs, statistics, things outside in research as well. Now, the cat paradox is essentially the following quote, originally from Schrödinger. A cat is placed in some chamber, some enclosed box, and the following setup is true. There's a Geiger counter that has a small amount of radioactive material, so small that it may decay within a certain amount of time, it may not. But if the material in the Geiger counter does decay, that will set off a measurement that will result in a container of cyanide gas being released inside the steel container. Now, also in the container is a cat. The cat is assumed to be alive if the cyanide container remains unbroken, and assumed to be dead if the cyanide container is broken. And what we are left to understand is that until we take some measurement, until we open the box to see for sure what's happening on the inside, really there's just some possibility, some probability that the cat is either alive or dead. So there's really some possible superposition of possibilities between whether the cat is alive or whether it's dead. We just do not know for sure until our measurement has been taken, until we look inside the box. And this basically gives two ways of looking at a measurement. When we take a measurement, is the measurement that we're taking the result of us looking for it? Simply the act of taking a measurement, does it cause the system that we're observing to choose one of the variety of possibilities it could undergo? For example, if we open the box, does the cat then decide if it's alive, or does it decide if it's dead? And beforehand, the system, when we're not measuring it, is under some possible combination of either one or the other. Or when we take a measurement, is it a measurement of some prior state? Before we open the box, is the cat already dead, or is it already alive? And then as we look into the box, is our measurement just what happens after the fact? Not something that in the process of measuring it caused the system to collapse into one option, dead or alive, but it was already a state that was true, and the measurement is just us looking for what was already there. Well, a less macabre way, less death way of looking at it could be a more colorful way. Let's just take the box example again. There's no way of looking inside the box currently. And let's just say at the roof of that box, once the lid is closed, there's a pendulum that's free to swing around. It's attached to some weak string, not really meant to hold the weight at the end of it. But as the earth is rotating, that pendulum is moving as well. And at the bottom of that box are pressure plates that connect to a light bulb. One pressure plate might cause the light bulb to turn blue, and if the pendulum, once it snaps, falls on another pressure plate, causes the internal contents of the box to turn red. So, after a certain amount of time, we're left to wonder, well, what was the current state, the internal state of the box? Which could be a variety of possibilities. If the string broke off, did it land on the blue pressure plate, causing blue light to be present within the box, or did it land on the red pressure plate? Did it land on both plates, causing some mixture, possibly purple, or is the string still intact and there's just no light within the box currently? And really, we're left to just wonder. All possibilities are possible until we really open up the box, and it won't really know for sure whether what we're measuring is just, once we open the box, the system then decides on collapsing on some possibility, or once we open the box, are we looking into what was already there? But that's just a more sincere way of looking at quantum mechanics, but representing it with a macro state. A lot of this is really just a oversimplification of what's happening on the microscopic level, where quantum mechanics is doing some very interesting things. But that was just Schrödinger's cat paradox and a personal, colorful, less death involved way of looking at superposition and measurements.